I imagine most of you have used or at least are aware of what a bolt and a nut are. That's a common way of fastening parts together. In this chapter 15 and 16, I'm going to cover thread notes, which kind of help you easily define what a threaded part would be and how to actually show a threaded part in a couple different ways in your drawings. I'm going to start with just understanding the thread notes, and then in the next video I'll show you how to make a threaded part. So I'm going to swap over to an Excel spreadsheet again to show you how to make a thread note and what each part means. So this is once again this SP problems in the back of chapter 15 if you want to follow along. So this first one here, let me get on the right page here, is an external thread. So meaning the threads are on the outside, and so like with the nut, it has a thread class of 2, which if we go to page, let's see here. So thread on page 1510, you can kind of read through what each of these things mean in more detail. The thread class indicates the closeness of fit between the two mated threading parts. 2 is usually what you'll see. If there is no class on the note, that means that it's a 2. Our major diameter is the outside diameter of the part, so the very outside of it. And then series is what kind of thread it is. So this would probably be a good example of a coarse thread. There's fine threads and extra fine threads. So to start our thread note here, the first part of the thread note is the major diameter, which in this case would be, I have 0.4375, so the fraction of that is what you want to put in there, so that's 7/16. And then the second part is the threads per inch, how many threads there are in an inch, which in this case we're going to have to go to Appendix B in the back of the book. And it should be the first chart once you get to Appendix B, chart B1. And then looking through this chart, we find our nominal size of 0.4375 or 7/16. And then there's 3 other columns: coarse, fine, and extra fine. And we have a coarse thread, so we find 7/16 and then threads per inch, and that would be 14. This next cell, which this is similar to what I'll be assigning to you on Canvas, it's a drop down. So you pick the series on this one. So this is a come on, UNC, a unified thread, unified national thread course, so UNC. And then this last bit here is your thread class, which is 2, and then it's, as you look at on page 1511, number 5 there, if it's external or internal threads, and A is external and a B is internal. We have external, so I'm going to put an A. And there is the note that this would create. I got this all set up in the assignment, so it'll automatically kind of build this for you so you can see how it looks. And then the minor diameter is where the inside of the thread, the root. To determine the minor diameter, there's an equation at the top of the chart on B2 in the Appendix B. That's the D, your major diameter, minus 1.0825 times P. Well, we haven't determined pitch yet. So pitch is just equals 1 over the threads per inch. Press enter. Now I can use that in my equation here. So I said it's your major diameter minus 1.0825 times P, pitch. And that didn't come out right. Oh, what did I do wrong here? Guess I'm just gonna double check to see. There you go. That makes more sense. So that's this process here. That's going to be the first assignment I have up on Canvas, and then number 2 will be the second one. Similar process. I have a thread class of 3. This one is, I believe, an internal. They say this is supposed to be an internal thread. Yep, internal. So that's going to be a B on our over here. So, and it's a series of fine. So I have a diameter of 0.5625, which is 9/16. Let's see if I can. Yeah, anyways, 9/16. I have, then going back to the chart, I find 9/16, and I find it's a fine thread, so I go to the fine column, and I have 18 threads per inch. And then dropping this down, it's a UNF because it's fine, and then it's a class of 3, and it's an internal thread, so B. An internal thread, like with a nut. And then there's the tap drill size, where the size of what you need to drill to make the part. So that's also in the chart. It's the second column underneath fine. There's the threads per inch and then tap drill. So finding that stuff again, I have a 33/64. And then pitch is, once again, 1 over your threads per inch, which I did not type that in correctly. 1 over threads per inch. There you go. Next one, they have, this is where you have to definitely go to the chart. Some of the threads will be designated just by a number. So a number 3, if I go to the second column over in the chart, it tells me the basic major diameter, which is 0.099. So I'm going to type that in, 0.099. And then in your note here, you just simply type in 3 for your major diameter. And then it is a, oh, that's right there. It's got, so it was a coarse thread, so I need 48 threads per inch. And then, once again, it's coarse, so UNC. Jumping over to metric, it's fairly similar with some minor differences. If you look at page 1513 in the text, it shows you each part of the thread. So the M just stands for metric form, and then in this case the 33, that stands for the diameter. I have a fine series, so I'm going to put in, I can just do this real quick. It's an M33 by, and then the other, after the X there, that's your pitch, which you're going to have to go back to your charts and find on the second page, B3. Look in that first column, find M33. Also, well, second column, I gotta go be in the fine column. Find M33, and it's got a pitch of 2. The minor diameter is similar process here. There's an equation at the top of the page. I take my major diameter minus 1.2075 times my pitch. And then the number of threads per inch is just like when you solve for pitch with the threads per inch, it's 1 over pitch. So in that case, 0.5. And then the last one here, I have an M24 course. Go to the chart. Well, first thing here, I'll put the M24. And then to find my pitch, I find M24 under course, which is 3. my minor diameter of 24 minus 1.2075 times the pitch. And then looking at the chart again, there is the tap drill diameter, M24. It's got tap diameter 21. And then once again, my 1 over pitch. So in the back of chapter 15, if you find P15-1 to P15-5, I'm going to assign each of those. They'll have separate Excel sheets that you can download, fill out, and then upload to me. They'll be auto-graded. Things to be aware of when you're filling them out, such as when you have the thread note where it's a fraction. So like I had a major diameter of 0.4375, I typed in the fraction there. I'd like you to do that as well, otherwise the auto grading is not going to actually update. Keep things capitalized as well. Those will be up for tomorrow, and I want you to do those at home so we can spend the time in class using CAD to create these parts and better understand them.